We will solve a problem in Advanced Engineering Mathematics 5th edition. We have here problem number 1, d cubed plus 2d squared minus d minus 2 times y is equals to 10 sine of x. We have the f of x here is in sine term. So we will use undetermined method of undetermined coefficient to solve for the general solution y is equals to yc plus yp. Yc is the complementary function for the homogeneous and the particular integral is for the yp. We have here that the equation is not in its original equation, it's in operator form. So we have d triple prime plus 2d double prime minus d prime minus 2d is equals to 10 sine of x. That's the original equation, and then we'll proceed. We have the auxiliary equation or the characteristic equation, d cubed plus 2d squared minus d minus 2 is equals to 0. To solve for our yc, and then we will factor it out. D times d squared minus 2d minus 1 and then minus 2 is equals to 0, and d is equals to 2, and then d squared minus 2d minus 3, we'll factor it out, and then we'll have a d minus 1 times d plus 3. So we have the roots of 2, 1, and a negative 3. This is a distinct real root in case 1. So our yc will be yc is equals to e to the 2x c1 plus e to the x c2 plus e to the negative 3x c3. To solve for the particular integral, we will guess an equation suited for the g of x, and we'll use a sine of x plus b cosine of x, and then we'll derive it. Y prime is equals to a cosine of x minus b sine of x, and double y prime is equals to negative a sine of x minus b cosine of x, but we'll need until y triple prime, so we have negative a cosine of x plus b sine of x. And then substitute the yp prime, yp double prime, and yp triple prime from the original equation, d triple prime plus 2d double prime minus d prime minus 2d is equals to 10 sine of x. So we'll have here, if we substitute, a cancellation of same equations. So we will have a negative 2a cosine of x plus 2b sine of x minus 4a sine of x minus 4b cosine of x is equals to 10 sine of x. And then we'll have separate the same cosines and sines, and then we have a negative 2a minus 4b times cosine of x is equals to 0 cosine of x, and for the sine of x, 2b minus 4a times sine of x is equals to sine of x. And then we'll equate this to, so we'll have the answer of a is equals to negative 2 and b is equals to 1. So we'll substitute this in the guess equation, and we'll have yp is equals to negative 2 sine of x plus cosine of x. And then to solve for the general equation, we have the yc now, the y and the yp. So we'll just add these two. So we will have y is equals to e to the 2x c1 plus e to the x c2 plus e to the negative 3x c3 minus 2 sine of x plus cosine of x. So this is the general solution of equation dq plus 2d squared minus d minus 2 times y is equals to 10 sine of x. Okay, we have a number 2 problem here. Using a method of undetermined coefficients, find a particular integral of y double prime minus y is equals to 1 over x. For what values of x, if any, is this solution meaningful? We have the equation y double prime minus y is equals to 1 over x. And then we have the characteristic equation, or the auxiliary, m squared minus 1 is equals to 0. And we have the root of positive and negative I. And then we'll have the yc is equals to c1 cosine of x plus c2 sine of x. For the particular integral, let's find an equation that will suit for our g of x equals to 1 over x. Okay, let's just guess ax squared plus bx plus c, because this is an x term. It's just a guess, so let's derive it. We have y prime is equals to 2ax plus b, and then double prime y is equals to 2a, and substitute this y double prime and y is substitute this on the original equation. We'll have a 2a minus ax squared minus bx minus c is equals to x to the negative 1, the inverse of this 1 over x. So we separate the a, and then we'll have a 2a minus ax squared is equals to x to the negative 1. But we can solve for the particular integral, because we can find the particular integral, and we can find the undetermined coefficients a, b, and c, because in undetermined coefficient, in terms of x to the n, the exponent n must be greater than 0 or must be a non-negative number. So the answer for this is the particular integral cannot be solved, and the solution is not meaningful.